All right, so even if you feel like you could fill this in, I want you to stay with me because I want you to see some patterns that are in here. But all of the radian angles are in there. All of the degree angles are in there for you already. We're going to talk about the ordered pairs, and then I'm going to give you another way to remember what's going on with the ordered pairs. So if you look just in the first quadrant, right? So just in the first quadrant here, you see all these are all over 2. And then you look in the second quadrant, all over 2. Third quadrant, all over 2. Fourth. The only ones that aren't are the ones that are on the quadrantal angles, right? Because they're just not fractions, and those will be like the zeros and the ones, okay? So when we go to fill in these, this is how it works. The numerators go like this. 3, 2, 1, 3, 2, 1, right? Then the numerators all have square roots except that this, what's the square root of 1? 1, so we just don't put a square root on it, so it looks like this. So when you're having to remember the unit circle as a whole, there's only 1s, 2s, and 3s. You just got to put them in the right spot, right? In the 45 degrees, these are the same. That should make sense. These two, the x and the y, just change places, right? Then quadrant 2, all quadrant 2 is a reflection of quadrant 1 across the y-axis. When you reflect in the y-axis, all you do is change the sign on x. Plus, you know quadrant 2 that you always have in an ordered pair, it's always negative, positive, right? So up here, this is 1 in the square root of 3. So the same little pattern happens with the numbers. This is 1, 2, 3, and then 1, 2, 3, and you just get the square roots on those numbers there, and you make sure you have the negatives on the x's. You see how that works? The third quadrant is just a reflection of the second quadrant in the x-axis, which means we change the sign on y. Plus, we've known for a long, long time that in quadrant 3, it's always negative, negative, right? So this point here, 7 pi 6 goes with 5 pi 6. And so these numbers are the same. Remember, we noticed that yesterday. And we just have to put negatives on them. And then we get 3, 2, 1, 3, 2, 1. And then we just square roots. But the x and the y are negative in the third quadrant. So it looks like that. Fourth quadrant, it's a reflection of the third quadrant, but it's also a reflection of the first quadrant. And we just reflect down over the x-axis. So square root of 3 over 2, 1/2 is a reflection down here. This is square root of 3 over 2, 1/2. But in this quadrant, we know that x is positive and y is negative. You got negative stuff right there. And then this is 3, 2, 1, 3, 2, 1. We put our square roots on them, make our y's negative, and we're good to go. And since, actually, let's fill in the other ones first, and then we'll talk about that. So what is this ordered pair right here? 1, 0, and this one is 0, 1, and this one is 1, 0, and this one is. All right, so now tell me, what is the cosine of 4 pi thirds? Ready for that? Cosine of 4 pi thirds. Remember how to figure that out? Here's 4 pi thirds, right? This ordered pair here. One of these two is cosine. Which one is it? The one over the negative 1 over 2. It's the x. Remember x, y, cosine, sine, it's in alphabetical order just like x and y is, right? So for 4 pi thirds, the cosine is negative 1/2. The sine is negative square root of 3 over 2. Okay, does that make sense to you? Now, since we know that all of our ordered pairs are cosine theta, sine theta, right? Then in quadrant 1, cosine is positive and sine is positive, And then tangent we find with sine over cosine. Remember that? So since tangent is sine over cosine, it would be positive over positive. So in quadrant 1, all of them are positive. In quadrant 2, okay, and that's because our ordered pairs are positive, positive there. In quadrant 2, your ordered pairs, you have negative x, positive y for all of them, correct? So your cosine values are negative because cosines are x. Your sine values are positive. Tangent is sine over cosine, right? So if I put positive over negative, it's going to be negative. We agree with that? So the only thing that's positive in the second quadrant is sine, and its reciprocal, which is what? Cosecant. So then quadrant 3 is negative, negative, right? So cosine is negative, sine is negative. But when I go to find tangent and I put sine over cosine, when I put negative over negative, what do I get? Positive. So all of my tangent values are going to be positive, as well as, what's the reciprocal? Cotangent. And then quadrant 4 is positive, negative. So cosine values are positive, sine values are negative. Tangent is negative over positive, so those would be negative also. So what's positive in the in the fourth quadrant is going to be cosine, and its reciprocal, which is secant. So here's how you remember this. If we really just think about sine, tangent, and cosine, then we know the reciprocals go along with it. First quadrant, all of them are positive. Second quadrant, sine. Third quadrant, tangent. Fourth quadrant, cosine. So there's a little mnemonic that goes with it. It's all students take calculus. And if you can put that in there, right there like that, you know what it is, right? You can get the right letters in the right place, okay? And then you know which ones are positive in those. Okay, we all good? All okay with that? Yes. All right. So sine theta, remember it is opposite over hypotenuse, which is y over r. And in this case, the radius is 1. Cosine is x over r, and tangent is y over x because it's sine over cosine. That means cosecant is r over y, secant is r over x, and cotangent is x over y. So I want you to be practicing your radians. We also have to know these ordered pairs. Like you've got to know this like the back of your hand. And on Monday, I'm going to give you a quiz, and you're going to get a circle that looks like this, but it's going to be blank. Okay, it's like the one I showed, one that I put up there the other day. Okay, but the only thing you're going to have to do on Monday, you're going to have to do is put in these radian angles. That's it. Okay, we're going to get to where you got to do it all, but we're going to start slow because remember we've got to learn it little bit by bit. I'm not going to drown you in this stuff, but you got to learn it all. Okay, we all good so far? All right, so I'm going to give you another way today to remember the ordered pairs. It's going to be really easy to do, so let's just hang on to that. Let me give you this. A minute. If you know them, that's plenty of time. But you have to know them. You're not going to have time to calculate them, like to actually do conversions and stuff. But remember, let's look at this. Well, let's look at the hand trick, and then we'll look back at this. I don't know that I think I put this stuff in the Quizlet. If I didn't, then I will make sure that I actually do that, and I will send you another little way to practice. But let's look at the hand trick, and then we'll come back and talk about the radians again. Okay. So check this out. Kind of explain to you. Mine's a little bit bigger, so mine is more accurate to the actual size of my hand, and I know yours is tiny and your hand doesn't really fit on there, but you're going to have to look at my fat fingers under this document camera too as we do this, okay? All right. Oh, hang on. I got to get this off of the screen. No. All right. So if you put your hand down and you put it palm up like so, right? And your hand, your open hand represents the first quadrant. Your pinky is the x-axis, okay? Your thumb is the y-axis. Does that make sense? So then your middle finger is like the 45 degrees. your index finger is 60, and your ring finger is 30. Okay, does that make sense to you? All right, so now, when I take that, let's say I want to look at 30 degrees, which is pi 6. So that's my ring finger. I'm going to fold my ring finger back so I can actually see the pi 6 and the 30, right? So then I have 3 fingers to the left. So 3 goes in the numerator, and that's over 2. And then I have 1 finger on the right, and I put 1 over 2, but it's the square root of the number of fingers you have over 2. So x is the square root of 3 over 2, y is 1/2. See how that works? So then for pi 4ths, which is 45, you're going to pull your middle finger back. Okay, so these are all going to be over 2, right? I pull my ring finger back because it represents pi 6, right? I have 3 fingers. So square root of number of fingers over 2, square root of number of fingers over 2. Okay, so look, now on when we do 45, it's definitely going to both be over 2. My middle finger represents pi 4ths, so I've got square root of 2 over 2, square root of 2 over 2. Does that make sense? That way you can keep them straight. So then pi 3rds is like your index finger. They're both over 2, so I can go ahead and write that down. And then I have 1 finger to the left of it, so it's just 1. We don't put the square root. And then I have 3, and it's the square root of 3. Okay. Everybody okay with that? Good. So that's what. So you're going to look like you're playing air guitar when you take your quiz. Okay, it's really kind of fun. You can do it with your right hand. You can do it with your right hand. Just you're like this. Okay. So if you can't use your left hand, if your left hand is in a cast, such as Tony's, if you can do the same thing with your left hand, though, it's just that this will be your thumb and this will be your pinky. Does that make sense? Just palm up is a little bit easier. Or you could do it like, I mean, you could do it like this, but you kind of have to turn it. But you put your palm up like this, and then you can do it that way. It'll work. Just, yeah. Okay. So now let's look at this one here. When I'm at pi halves, I'm going to pull my thumb back. How many fingers do I have to the left? 0. How many fingers do I have left to the right? 4. What's the square root of 4? 2. Divided by 2 is 1. It is. Like this one you should just know. I just want you to see that it works for that too. So for here at 0, if I pull my pinky finger back, I've got 4 on the left. Square root of 4 is 2. Divided by 2 is 1. And I have 0 fingers over here. So yes, you're right. That's the hard way to get those 2 points, but it does work. Okay, but the hand trick truly is a lifesaver to keep these numbers in the correct place right here. Does that make sense to you? It's easy, but you got to make sure you know how to use it and actually try to use it without just looking at your unit circle the whole time. Okay, so let's look back over here because I know y'all are freaking out over this little quiz that's coming. But remember this, you've got patterns here. So let's look at some of the patterns. You should be able to get 0 and 2 pi pretty easily, I hope. Pi pretty easily, right? Pi halves, 3 pi halves should be no-brainer at this point because we've talked about it so much, right? Okay, so if you can get those down, like let's do this. Let's tell you what. We will let me open this. I was gonna try, I don't have a blank one. I'm just gonna do this. We're just gonna draw a circle. It's gonna be bad, so you could draw it on the back of something, or draw it on your little blue one if you have room, or some on the bottom of the pink one. It doesn't have to be big. So my circle is gonna be horrible. Oh no, look, I can cheat. I can cheat. Look at that. Okay, so it's orange. Okay, so here's what we know. We've got this. This is 0, and it's 2 pi, right? So instead of just going straight around the circle, you can do it in pieces. I can come over here, so I know that this is pi, right? I know that up here, this is pi halves. And then down here, what's this? 3 pi over 2. Okay. So is all that simple enough for everybody right there? Yes? Okay, halfway between 0 and pi halves, what's halfway between 0 and pi halves? Pi fourths, right? So now that I have that, this is 1 pi fourths, this is 2 pi fourths, halfway in between again is 3 pi fourths, pi, which is 4 pi fourths. And then I get 5 pi fourths. Then 3 halves is 6 pi fourths. So this is 7 pi fourths. And then come to here and I get 8 pi fourths. Okay, everybody okay with all that so far? All right, so then I've got these that go here, the 30s and the 60s, right? And they're not really halfway in between, but they're somewhere right about here. It's good enough for this anyway. It's not perfect, and that's all good. It's pretty darn good, but it's not perfect. All right, so we know that the one that is closest to 0, is that going to be pi thirds or pi sixths? Sixths. So this is pi sixths. So then this is pi sixths, this is pi thirds, right? All of the ones that have a 6 in the denominator are closest to the x-axis. So all of these are the 6s, right? Which means the rest of them are all the 3s. Okay. And so if you count, you can count the whole thing in sixths and just reduce, right? So like this is 1 pi over 6. This would be 2 pi over 6. That's where that comes from, right? Reduce. This is 3 pi over 6. This will be 4 pi over 6. What does that reduce to? 2 pi over 3. So since that was 4 pi over 6, this is 5 pi over 6. 6 pi over 6 here. 7 pi over 6. 8 pi over 6, which would reduce to 4 pi over 3. 9 pi over 6. This would be 10 pi over 6, which is 5 pi thirds. And then this is 11 pi over 6. So then check out this pattern here. Okay, if that whole counting around there is difficult for you, look at the relationship between the numerator and the denominator in the second quadrant. The numerator is 1 less than the denominator on all 3 of them in the second quadrant. You see that? In the third quadrant, how's the numerator and denominator related? The numerator is 1 more. Here the numerator is 1 less. Here the numerator is 1 more. If you can get the 6, 4, and the 3 in the right place, the other ones should be pretty easy, right? But it's also what's good for you to practice is drawing your own blank circle and start filling them in and thinking about it that way. Okay, instead of just staring at a done unit circle. And then this one here, you're really just going to have to remember that it's 2 more, it's 3 more, and then it's 5 more, or it's 5, 7, 11. Like they are all prime. Okay. So however, this one you kind of have to do whatever makes the most sense for you. But there's lots of patterns in there, but you're not going to see them if you don't start just writing it out over and over again. Use some of those flashcards that are in Quizlet, and then there's a game that I'll send you the link to where these, basically the points are there, but these angles are not, and it gives you this angle. It'll say 11 pi over 6, and you have to click on this point. It'll give the other one, and it's really good practice that you can do it on your phone, and you can practice over and over again. Okay? Any questions at all? You ready for the quiz right now? No, but and then the next day we'll do a little bit more. Okay? Just leave it up. Yeah. Okay. Any questions? Yes. Okay. If there's no other questions on this, go ahead and glue in or tape these in. Probably tape is better so you can flip this.